So this is the third and final talk. So to recap, we've had a Climate Change 101 talk from the global story to local impacts. Secondly, we discussed how climate change relates to Reclamation's different mission areas and communities of practice, and tried to spur thinking about what types of climate changes could occur, what are most relevant, and put you kind of on alert to know that you're going to have to make judgments about what information is reliable for what levels of action. Moving forward, this is going to be more of an opportunities kind of talk. I'm going to be discussing in this third talk what tools are available to help us address climate change in Reclamation's different mission areas. This talk was a team development effort. Received help from Jennifer, I always say that. Chuhajian, thank you. Jennifer Chuhajian, Jennifer Johnson, and Carrie Hessman from Pacific Northwest region, and so thanks to them. Okay, moving on. My slides are frozen. Here we go. Okay, so the outline. We're going to focus on the same 5 mission communities as Talk 2, and we're going to identify existing tools that support missionary activities, starting at a very high level, like what are the steering, persuasive tools that underpin our activity areas, what are some assessment reports that can be leveraged, what are some data and guidance technical tools available, and what are some training opportunities available. So to hit that list again, I'll have another slide here in a second, but just to reorient, the 5 mission communities we're talking about are infrastructure management, dam safety, species recovery and adaptive management, long-term planning, and reservoir operations. So I'm going to walk, this is kind of a more detailed preview of the slides to come. It's an outline of the tools that I'm going to describe. So I'm going to start with a couple of high-level steering tools that are Reclamation specific, our corporate-wide climate change adaptation strategy, and also Reclamation's climate change adaptation policy. I'll also list a few other high-level steering tools that aren't in that list. I'll mention them later. Then I'll segue to assessment resources that can give you a head start on building intuition, or maybe even information that you can adapt to your own study contexts. A lot of these are supported through our Water Smart program. Next, after that, I'll focus on some technical tools and then training opportunities. So let's begin. We'll start off with those high-level steering tools. So the first that I'm going to make you aware of is Reclamation's Climate Change Adaptation Strategy, which was issued November 2014. The strategy, builds on past activities. So in the introduction, it recognizes that we've been trying to get our arms around what climate change means in different corners of Reclamation for different mission areas and making progress. And so this strategy builds on that progress. The overarching goal is the strategy aims to communicate both internally and to the public and stakeholders how we can pursue mainstreaming or integration of climate change considerations into our management practices where it makes sense. So there's 4 strategic goals in the strategy. Basically, these goals serve as an outline for activities and whatnot. I'll have a slide on that in a second. So increase water management flexibility, enhance climate adaptation planning, improve infrastructure resiliency, and expand information sharing. In the upper right, you'll see the 5 community graphics, and when they're solid outline, I'm suggesting that the tool on the screen is likely applicable to that community. When they're dashed, it may be applicable, but it's more for that community to judge. A couple more slides in the strategy. Under each of those 4 strategic goals, there's a progression of thought described in the strategy. The green box, it recognizes that we need to develop guidance, science, and capacity, or more specifically, develop the technical and personnel capabilities that will allow us to achieve that goal. Close at hand with the green box is the purple one, where we initiate pilot studies to kind of flesh out how we consider climate change within a given goal area. And then lastly, the blue box is after we feel confident about the pilot study results and demonstration results, confident enough that those methods are robust, we can formalize them into processes that apply going forward. So for example, development of directives and standards that will go under the Reclamation manual. This is a one-table summary of the content, of the more specific content of the strategy. Moving left to right, the 4 strategic goals are on the left, the row headers. The middle 2 columns are implementation actions, and the right column is the envisioned end goal that will be achieved by implementing these actions. Drawing your attention to the middle 2 columns, the second column is just a high priority action pullout of the bold item in the third column. So, for example, that first row, increased water management flexibility. There's a lot of implementing actions, but the one in bold is Reservoir Operations Pilot Initiative, and it's labeled as the high priority action in the strategy. And I'll have a slide later on what that is. Likewise, down the third row, improve infrastructure resiliency. There's several implementing actions, and the high priority one are the dam safety climate change assessment pilots. And so I'll have a slide on those as well. Okay, pivoting from strategy to policy. So strategy basically, it sets a vision. It describes what Reclamation is trying to communicate, what our vision is, where we're going with integrating climate change, where it makes sense. Punctuating support for pursuit of that vision is the fact that we now have a policy in the Reclamation Manual as of March 2015 that is Reclamation's first climate change adaptation policy. And the reason we have it is because basically the Department of Interior said, you will have this. And the Department of Interior issued their first department manual chapter on climate change adaptation back in December 2012. It calls for a variety of things, one of which is to integrate climate change into our management approaches where it makes sense. So we're following suit and putting in the reclamation context. Other federal high-level steering to be aware of, there's 2 that I'm going to highlight here. The first is something called principles, requirements, and guidelines. For water resource investments in the U.S., investment evaluations in terms of costs and benefits have been evaluated in the context of principles and guidelines since the early 80s. And the principles themselves were evolved and released, an updated version were released as principles and requirements in 2013. The associated guidelines are in development, and last I heard there's an updated draft or a new version going to be proposed later this year, but that's still a wait and see. Back to the principles and requirements, what's new with the new 2013 updated version is that while we invest in water resource, we consider water resource investments as we consider them, we also have the philosophy that we want to foster and maintain healthy and resilient ecosystems. So that's called out as a new update or a new emphasis in the new principles and requirements. And also a new emphasis under general requirements is to consider the risks and uncertainties of climate change. So it's saying that you should consider these things. It doesn't say how yet, and the how is going to be addressed in the interagency guidelines that are still in development. A second high-level steering activity that's also in flux is NEPA guidance being developed for the federal community, led by the White House Council on Environmental Quality, or CEQ. They're looking at NEPA guidance from the 2 sides, or from 2 points of view. The point of view we've been really talking about today is how might climate change affect some actions that we're proposing. So what's the climate effect on the proposed action? But you can also ask the question in reverse. What's the effect of the proposed action on local climate or global climate? And that is a touch point to connect any proposed actions we look at to potential greenhouse gas emissions inventories, or what's the emissions associated with our action implementation activities. The approach to how to deal with both questions is being addressed in the NEPA guidance, and they aren't finalized. One interesting issue on the second question of what's the effect of the action on climate, there's a question. Oh, great, yeah. I was just going to say the emissions of greenhouse gases from reservoirs has been a topic of interest, of increasing interest in the last couple of years. In Reclamation, the Army Corps of Engineers and Department of Energy Oak Ridge National Lab, we're co-sponsoring a technical review on methods available to characterize emissions of greenhouse gases from reservoirs. And the main gas of interest is methane. So as organic material floats into a reservoir, settles, it decomposes and can belch and emit methane. It may be small, but we can't show that it's small because we don't have good characterization methods. So it's one of those questions right now. And there's a question in the room.
Well, the question was similar, but I mean, it was how the project affects greenhouse gases. And I guess one of the things, would it be, hydropower would take away effects that a gas power plant might have, so you're reducing potential impacts of greenhouse gases. Would you look at that as well, or just?
That's a great question, and I don't know the answer. I know that folks in our Power Resources office are interested in how do you attribute greenhouse gas emissions to reclamation operations for hydropower or otherwise. And a contact there is Mike Polskamp, and he's been kind of trying to organize thoughts around that issue, but I think it's still a work in progress. Okay, so last slide on high-level steering. This is more of a region-specific slide, and Jennifer helped develop this one. Within your region, you have a region climate change coordination group that meets monthly. So it's an opportunity to connect and learn about developments of using this, of integrating climate change into your work. And there's also a regional website where you can learn about region activities as well. usbr.gov/pn/climate. So now we're going to move from high-level steering to those assessment reports. So the second category of tools. And the theme in this category is give you a boost or give you a head start. That's kind of what the idea is here, through assessments where information's been digested and summary messages have been produced or summary information's been produced. So the first type of an assessment report that could be useful for your more local planning efforts are these water smart basin studies. A basin study is similar to an appraisal level study, which we heard about in the second talk, that the long-term planning community undertakes. And again, these appraisal level studies are kind of shallow depth evaluation of some candidate proposed actions. Ingredients of a basin study, there's 3 required ingredients, among others. The first is listed on the slide. It has to feature an estimate of future water supplies and water demands under at least climate change conditions, but potentially other future stressors. It has to show an assessment of vulnerabilities for future operations and or infrastructure under those future supply and demand conditions. And then thirdly, it has to show development and shallow depth evaluation of some options that would address those future vulnerabilities. So it's a shallow look at adaptation strategies. So there have been 5 basin study efforts funded in PN regions since 2009. Another very important characteristic of these is that they're federal, non-federal, cost shared. So Reclamation pays for 50% of the study, and the non-feds bring the other half to the table. So it's a great example of fed-non-fed collaboration. So the output of these studies, they're useful for developing intuition of potential climate, supply, and demand changes in that basin, and you can extrapolate what that might mean for your more specific resource management questions. An example basin study is the Hood River Basin Study. I'm going to let Jennifer say a few words about this one.
Okay. This was a study that we did out of our office here in Boise. It had kind of 4 key parts. It began with defining current and future water supply and demand in the basin, and this is just kind of characteristic of any basin study. We also looked at the impact of climate change on the performance of existing water delivery systems, and we developed options to maintain water delivery and adequate supplies going into the future. And then the last part was a trade-off analysis on the various options. And I think this is published now. Yeah.
That's great. Okay, so the next assessment report, let me get the mic back on, is a literature synthesis that has been supported by the Science and Technology program in the Research and Development Office. The idea here was to make your lives easier when you have to summarize recent climate change science and impacts for planning documents. So produce boilerplate narratives that you could copy paste and hopefully easily adapt for your planning studies. Save you time, save you money, save you headaches. And also promote a more consistent narrative of the summary of the science across planning documents, so you don't have each team figuring it out on their own. So the third edition was released in 2013. The next one will probably come out in 2016, roughly time frame. The first edition came out in 2009, second in 2011. Within these, you'll find region-specific narratives on historical climate trends over that region, observed hydrologic impacts, projected future climate and hydrology changes, and implications for various water and environmental resources. So hopefully you find these narratives useful. We've applied them in various studies from the Denver offices, and other regions have also been applying this synthesis as well. Also, the synthesis has like a glossary of key terms. You might find that useful, like definitions you can apply for your studies, or your documents. And also there's a big appendix of maps, climate change graphics. And they probably won't be useful for copy-paste purposes, but they might be useful for just scoping discussions or informal conversation with study groups. So invite you to look at those map change graphics as well. Next assessment report, back to WaterSmart. WaterSmart has this group, WWCRA, that's a West-wide climate risk assessments team. There's members from all 5 regions, plus Denver Technical Service Center and Policy Administration. Their goal is to make future water supply, future water demand, and other future impacts assessment information available to folks in the 8 major river basins that are called out in the Secure Water Act. Those are the Missouri, the Columbia, the Colorado, Rio Grande. This map doesn't outline the full basins of interest in the Secure Water Act, but it's highlighting that there's basins throughout the western U.S. So the first called a multi-basin consistent assessment that was done focused on surface water hydrology impacts. It was issued in 2011, March 2011, and it sat underneath the first Reclamation report to Congress under Secure. This report in 2011 describes future climate changes on a seasonal basis, future runoff changes on a seasonal basis. An update to this is due late this year, and it's going to support the next report to Congress, which is also due next year. The flip side of the coin, that was supply side. This WWCRA or WICRA team also is focused on the demand side, and in February 2015 they issued a water demand and reservoir evaporation impacts assessment using a common methodology for all these basins in the West. And this map on the left, the report cover more accurately shows the basin's extent of concern from secure water. Within each of these basins, on the irrigation demand side, they focused on the physical connection between climate change and crop irrigation requirement at the unit area scale or the field scale. The report does not concern itself with socioeconomic influences on ag demands like market forces or technology, irrigation technology, or within an irrigation district, their mix of crop types, for example. So this is on a unit area basis. And then also the report does break apart these really big basins into smaller watersheds, or there is actually HUC 8, Hydrologic Unit Class 8 from the USGS system of watersheds classification. And within HUC 8s, you can find information about changes in unit area crop irrigation requirements throughout the calendar year. So it's a good head start for starting to develop demand change assumptions that you'll have to interweave with other local factors affecting demand. On the reservoir evaporation side, same idea. There's information on projecting changes in reservoir evaporation rates for reservoirs throughout the West. This is an additional slide prepared by PN folks. I'll let Jennifer talk a little bit about this.
So what we've done here in the PN region with the report that Levi just mentioned is take a step further and take the changes that were in the report and translate them into monthly and daily demand time series that we can then go and use in our planning models for basin studies and that sort of thing.
So that's great. That illustrates the intent of the report to try to give modeling groups like Jennifer's a head start in setting up planning assumptions. Okay, another assessment report that is being supported by WaterSmart, also being led through this WICRA team, are impacts assessments. So an impacts assessment initially looks just like a basin study. In fact, the first two ingredients of a basin study are in the scope of an impacts assessment. So you estimate future water supplies and demands, and you also assess vulnerabilities to ops and infrastructure under those future supply and demand conditions. But what's missing from an impacts assessment is that third step of developing options for adaptation and evaluating them. So the idea of an impacts assessment is to make it even easier for non-feds to come to the table, for reclamation folks to work with them on a basin study, knowing they can leverage information from an impacts assessment and just focus more of their energy on that third step, developing options. That's kind of the idea of the utility of an impacts assessment. And you have one happening right now in the larger Columbia River Basin. It's due to be completed in FY16. It's developing future runoff and supply information for a lot of locations around the Pacific Northwest under a set of future climate scenarios that kind of span the range of projected possibilities, and for 4 flexible future periods for near-term planning in the 21st century to the 2040s, 2060s, and the distant 2080s. And with that, do you want to say any more? Okay. So we're going to transition now from assessment reports that can be leveraged to more technical tools. So the first more technical tool is a website where you can access future projections of what we call downscaled climate and associated hydrology projections. So downscale is jargon. All it means is you're taking results from a global climate model that simulates weather and climate conditions over Idaho or Oregon or Washington at very crude, coarse, large resolution. So like a grid box in a climate model might be, there might be a couple grid boxes over the upper Snake Basin. It's very, very large grid boxes. And that's not really relevant to our local planning. So we can apply understanding of local relations between local weather and larger atmospheric circulation through simple statistical methods or more sophisticated atmospheric simulation, what they call dynamical methods. And but that generic process, either way, from simple to complex, is called downscaling. And so there have been methods available to do this step for a good couple decades, and Reclamation started to work with the simple one developed by University of Washington, partnering with others to apply that method that UW developed, and first launched this website in 2007, and it was making available a large set of future projections of monthly precipitation and temperature. We then added a methodology that had a daily resolution in 2011, and then also in 2011, focusing just on the Western U.S., we translated those future climate projections into hydrology projections in a consistent fashion across our Western U.S. 17 states. Moving forward in 2013 and 2014, we updated both the downscale climate projections and the hydrology projections to tier off of updated global climate projections. So you might have noticed that acronym CMIP3 on the preceding slide, and now on this slide CMIP5. That's jargon again, but it's referring to the global climate modeling community's phased experiment, or call it a generation of global climate models. So the most recent generation of models participated in this experiment, CMIP Phase 5. So this website, you can access information. There's a tutorial on how to use it. Some of the training I'm going to mention later also instructs on how to make use of this website. And those assessment reports that I just described, many of the basin studies, many of the impacts assessments, the S&T literature synthesis, map graphics, they all leverage this website's more specific data. So it's data that underpins a lot of our assessment activities. So I invite you to get familiar with that. Some specific PN region technical tools and resources. I'm going to let Jennifer talk a little bit about these.
Okay, so in our region, we've developed a lot of capacity to do climate change analysis and different types of hydrologic modeling. We try to stay really state of the art, and we collaborate with universities and other agencies quite frequently on our efforts. We have a whole suite of modeling tools, and we seem to add more every year. So we have a good technical staff here to answer questions and help with future studies.
And this slide shows the example in the top graphic there is a model where they input assumptions about future water supplies and future water demands and simulate how the reservoir systems and river systems could be managed given those supply and demand assumptions and other assumptions about management constraints.
Yeah, and then the bottom graphic is actually a tool that we developed here. We're calling it ArcVic. It's a arc map interface to the Vic hydrologic model. So
that sounds interesting. Hopefully you guys are talking with the Technical Service Center folks. I bet they would be interested in that as well. Okay, readjusting the mic. Okay, moving on. So that's data and model tools. Also kind of in the technical realm is our guidance development activities. So I'm going to have 4 slides here of guidance development that kind of map to some of the different mission communities that we were talking about. The first one is guidance that is available. It's been developed for the long-term planning community. The initial motivation was recognition that Reclamation updated its feasibility studies, directives, and standards in September 2012. The update to that included a very interesting change. The new feasibility studies DNS now requires the effects of climate change to be considered in the future without project condition, or you might call it the future no action condition. This departs from past practice, at least in other regions of reclamation, where if they considered climate change in a feasibility study and maybe an associated NEPA study, it was likely to be considered in a parallel analysis called an appendix, where they explored the sensitivity of the feasibility results or the NEPA effects disclosure to a different climate assumption, like a different future climate assumption. But they kept in the default analysis and the default future no action assumptions persistence of historical climate or just historical supplies, implying a persistence of historical climate. This motivates a pivot to making a judgment of what climate change information is relevant enough, reliable enough, and can practicably be integrated into that future no action condition. And making those judgments are important because when you do that, you are now imposing climate change into the decision support context. Before it wasn't mapped there because it could be just presented as an appendix, a parallel appendix. Now it's going to be folded into the decision support context through the future no action. And that assumption carries forward into the action alternative assumptions. So a team of technical folks throughout Reclamation and long-term planning process experts, call them project managers, program leads, they worked together for the better part of about 1.5 years to develop this guidance document. And really the bottom line punchline of this document is a series of 9 questions that folks are invited to consider as they scope what they want to include about climate change in their future no action. So there's questions to help navigate the question of what's relevant. There's 3 questions to help navigate the question of what's reliable. And there's 3 more on what can practically be done given that this study has limited time, limited resources, limited capabilities. For more information, you can contact Catherine Dahm, and this guidance document should be available on the WICR website soon, if it's not already available there. You'll also notice that I highlighted in the upper right that I would argue that this guidance development is relevant to all 5 MSHA communities. Even though these communities will consider different types of climate changes, they may not consider specifically feasibility studies, but that same paradigm of judging what's relevant, what's reliable, what can you practically consider into your analyses, you could flex that and apply that in other contexts. Okay, 3 other guidance documents that are more in they're less mature, they're in the process of being developed. I'm going to first talk about infrastructure management. I mentioned in talk 2 that our Reclamation 2015 budget appropriation includes funds to help us begin to integrate climate change considerations into extraordinary maintenance planning. So again, extraordinary maintenance, it's not routine O&M that happens year to year or every few years. It's like kind of big, major replacement repair activities where once you do it, that new infrastructure, repaired infrastructure, replaced infrastructure is going to have service life for a very long time. With extraordinary maintenance planning, there's 2 phases of interest. There's the project development phase, which may play out over a year or more, and then there's the phase of making a decision on which projects move forward and get funded, given that we have limited budget resources. The outcome of this FY15 pilot is hopefully going to inform guidance development that's going to start in FY16. The right side of this plot kind of walks you through, takes you down a level to how the pilot's envisioned to play out. And they're kind of in the initial phases right now. But they want to choose an extraordinary maintenance project. They want to focus on an extraordinary maintenance project that's recently been developed, for which there seems to be some potential to adapt it to a drifting climate. And if they do, they want to make sure it's something where there's some cost share flexibility to respond to. And there's other considerations here in this first box selection. The second box is then to start the conversation about what types of climate change matter most for this particular project from box 1. So that's going to involve consulting internal design experts so they can explain what weather assumptions, hydrology assumptions influence their design and specking activities. It's going to involve talking to the climate leads from WICRA. I mentioned in the second talk that there's some interest in whether there's going to be water pH change as carbon dioxide changes, and will that affect corrosion potential and preferred coatings, et cetera. Third box, after they identify the more relevant climate change criteria and access information, they'll review observed trends and expected future trends and make judgments on what information is reliable or applicable. Fourth box, they're going to evaluate impacts on the project development then, like how would the design have been changed, how different costs or different statements of expected performance. And then lastly, in parallel, it's really not last, but in parallel to these first 4 boxes, they're also going to be thinking about that second phase of multi-project consideration and adding climate change as a criterion to the mix of other factors that guide project selection. So that's what's happening now. If you want more information about this, I have contacts at the end, but it's being led by the Policy and Administration Asset Management Office, and Power Resources Office is also involved. Because power side XM, water side XM, they have different finance models, or call it payment models, if you will, like where the funds can come from. And I wish someone was here to say what I just said better. Okay, moving on to another guidance development area, dam safety. I mentioned in the second talk, Dam Safety Office and the TSC Flood Hydrology Group are teaming to start figuring out how to integrate climate change into the hydrologic hazard assessments that are done in that first phase, that shallow risk assessment, their comprehensive facility review that happens every 6 to 8 years. And then the second phase, an issue evaluation, a deeper dive risk assessment that's really confirmatory. It's meant to confirm any flagged potential risks from the screening level studies. So for for application and screening level studies, TSC issued a report in February 2015 that illustrates how they could potentially integrate projected average monthly stream flow changes, overlay that on their hydrologic hazard assessment, and let that bear influence on their screening level study results. So that's a first cut methodology, if you will. Second, the second pilot that was happening in parallel, it's situated at Friant Dam, California, on the upper San Joaquin River. So it's like south of Sacramento, runoff from the high southern Sierra. And in this, there is an actual ongoing issue evaluation happening at Friant. And they did the original hydrologic hazard analysis in 2013. That analysis uses something called a stochastic event flood model. It's a fancy name. They're just trying to simulate watershed conditions and the uncertainties affecting the relationship between storm precipitation and flood runoff, and ability to control that runoff through operations at Friant and whatnot. So they developed a methodology to flex the flood runoff assumptions and also to apply that in this stochastic modeling context. And so the second report is close to being finalized, and they're embarking on a next phase where they're going to learn how their risk assessment team reacts to this information and how it can be integrated. So the risk assessment team is going to consider not just hydrologic hazard, but all types of hazards for Friant. And the next learning lesson is this information something that can be easily consumed in the risk assessment context? What's more consumable, what's less, and that's going to be a process lesson learned as far as what comes next. Another pilot area that they're going to focus on, besides Friant in the near term, is Taylor Park Dam, Colorado. I mentioned that before. They have different flood generation mechanisms there, more related to heavy thunderstorm, convective thunderstorm possibilities. And eventually, these types of pilot studies, as well as probably others, will inform development of more formal guidance for screening level, using climate change and hydrologic hazard analysis for screening level studies, for issue evaluations, and for corrective action studies. So I'll connect a dot back to the talk number 2. The fact that PN region has some additional issue evaluations happening at Grand Coulee, Island Park, and I forget the third. Lessons, what was the third one? Deadwood, thank you. Lessons learned from those 3 will be valuable to integrate with the lessons they're learning from Friant and what they will learn from Taylor Park. So make sure that the TSC folks are aware of what you're doing. Last guidance development activity that I'll mention is speaking to the short-term reservoir operations community. So again, remember we were saying that their big challenging question is, when is it time to start nudging our criteria or updating our operations criteria? So this team, they've been assembled now for a little over a year, and they have members from all regions. From PN region, Eric is here in the room. He's the member for PN. Ted Day was on an early portion of this team, and they've landed on a vision for how they might develop a process model that is, you can see it's inspired by the Dam Safety Office's risk management process. So with dam safety, the idea with dam safety is to maintain awareness of changing watershed, changing structural conditions, and check every 6 to 8 years. Are conditions changing? Are hazards changing? Do we need to do something about it? Likewise, with reservoir operations criteria, you can apply the same kind of paradigm. Are climate and hydrology conditions drifting? We can check trends every few years. We haven't decided that frequency yet. And if it appears that there's a significant climate trend or hydrology trend that's been observed, or a compelling one that's confidently projected in the near future, maybe that'll trigger then a deeper dive evaluation. Okay, let's confirm that this information suggesting trends is really being interpreted right. Let's confirm that the effects on operations are being interpreted right. And if that confirmatory analysis supports what kind of came out of the shallow analysis, that could kick off a risk mitigation step, which in this case, rather than a corrective action study at a dam, it would be a criteria update study. And in a criteria update study, you're probably then going to interface with the long-term planning community because you're getting into their world. It's now you have a proposed action of new management criteria. They're going to have multi-year to decade or longer lifetime. So it's a model that should look familiar to folks familiar with dam safety risk management. It seems like it can be adapted to this criteria fitness risk management, if you will. They're currently drafting pilots to test out the first and third phase of this, what it might look like to help shape it better. And the contact and policy administration is Catherine Dom. She's the lead facilitator of this team. Okay, I'm going to now pivot to the last section, the fourth section of the talk, from technical tools to training opportunities. So the Science and Technology program, the Reclamation through its Science and Technology program has been working with other federal agencies and also the UCAR Comet program to develop climate change training capacity. The federal group that's banded together, they're banded under this Ad Hoc Climate Change Water Working Group, or CCOG. And as I said, Reclamation and CCOG members were working with a group called UCAR Comet. So UCAR is University's Corporation for Atmospheric Research. And before, let me just pause. I guess we have a comment from the line.
There's a 15-minute tutorial on the website, on the Comet website, on CMIP 5.
Okay.
We have that.
We'll come back to that in a second. So Comet is a group of folks. It's a program in the University's Corporation for Atmospheric Research family of programs, and they're situated in Boulder, Colorado. And they have a lot of experience developing training courses for professionals. And a lot of their legacy was born out of developing courses for the weather forecasting community. And National Weather Service leaned on them and Comet built tailored courses for the Weather Service. In the last 5 to 10 years, Comet has broadened and they've really gotten more involved in serving the water resources community. And Reclamation and the Army Corps have been working with Comet in the last 5. And as we got the comment on the web, Matt Kelsch from Comet, he's joining us remotely today, and Matt mentioned that if you go to the Comet website, you can find access to online, free, self-paced courses on a variety of climate, weather, and hydrology topics. You just have to sign up and register, and you can search for content. And specifically on learning about CMIP 5 and the recent generation of global climate models, they have some short, brief orientation content on that as well. So I invite you to check that out. So back to some of the training course developments that we've been co-sponsoring. Started in 2012, motivated by recognition then that we had limited staff expertise, particularly technical staff expertise. And so initially we focused on developing a new course series called a Professional Development Series for instructing natural resource specialists, analysts, engineers on how to assess natural systems impacts under climate change. Where you'll see what I mean, that's a broad set of subjects under natural systems. Main support's been from Reclamation and the Corps, but we've also been working with NOAA RESAs and like, as I said, UCAR Comet. So about that technical professional development series, when we said natural systems, we're talking about surface water hydrology, response to climate change, crop water demands, different types of ecosystem response. Courses are envisioned. The first one that we've delivered is water temperature, sedimentation and river hydraulics response, and also sea level change. These are all have been scoped at some stage or have been delivered to this point. But for each of them, the idea is that the student who takes the course will learn how to incorporate climate change information into impact studies focused on these resources. So pilots offered to date, the green outline around those boxes points to an online self-paced free course. Takes about 4 hours, but it's generally applicable to any of these impacts assessment areas, and it's how to prepare the future climate-adjusted weather inputs for a generic type of an impacts model, and how to do so in a way that you represent a range of future climate possibilities. So it's a general purpose online course. And it shows you how to start with that website that I mentioned earlier, those downscale climate and hydrology projections. It walks you through how to interpret those. It walks you through how to retrieve them and boil down those mini projections into just a handful of change scenarios. And then take from those that handful of change scenarios how to develop weather input time series for impacts models. We then put that course into practice through some instructor-led offerings. 2013, we had a hydrology course, instructor-led, mix of fed and non-fed students. We also had a crop water demand course in 2013. 2014, we converted the hydrology course from a residence experience to a virtual remote experience, and we reached a larger set of students from many locations. Also in 2014, we had a water temperature course offered. 2015, February, we offered a sedimentation impacts course. And planned pilots coming up we're going to do a virtual offering for hydrology again. And also we'll develop cores leading to the development of a sea level change and coastal vulnerabilities impacts course. Now, that's a lot of focus on training technical staff, but hopefully the theme is clear today that with our new strategy and our new policy, there's going to be a lot of non-technical people that are going to play a role in integrating climate change into our activities. So we see a need and an opportunity to offer general audiences training and structure that training to kind of speak to these 5 different mission communities you've been hearing about today. So kind of the same idea, we're going to develop a general purpose, online, self-paced, high-level training module about general principles of climate change, integration into water management. And then in the years to come, we're going to develop these instructor-led, more community-specific experiences. So anyway, that's what this slide pretty much sums up. Last slide on these training pilots is more of an advertisement. Currently, we have the schedule on this may slide, but just put out there, it will be delivered, and that is a second virtual offering of hydrologic impacts under climate change. So students who take this, they'll get basically exposed to hydrologic modeling 101 using a really simple hydrology model, so you shouldn't be intimidated. You'll be coached on developing hydrology weather model inputs to drive the model simulation and adjust the weather inputs for a range of future climate scenarios. You'll learn how to generate and interpret hydrology model results and be coached on how to communicate the impact story based on the hydrology model results. It's a 3-day experience, free tuition for Reclamation students, no travel required. You can do it from your desk, do it from a conference room with a group. There's plenty of capacity right now. I invite folks to approach me if you have questions, but still open to sign up. And we'll distribute information about this as well after the seminar. So last couple slides, you've heard about, this is a summary of the tools you heard about in this talk on the left, and just crosswalking the columns, it's the 5 different mission communities, and just my opinion on where the tools may be likely relevant. Those are the bold X's, and where they could be relevant are kind of the question marks. We'll distribute these slides to folks and make them available so you can look at this at your leisure. And then also, if you have questions about about these various tools, I'm providing lead contacts for each tool, from HighLevel Steering to assessment reports to technical tools and training. So we have time for questions. Yep.
Yes, I mean, you outlined several pilot, basic approaches. How are we going to kind of test our design approaches to integrate climate change into decisions, so we can continue to meet our purposes of our projects? And if you go back one slide, I was just thinking about, kind of these boxes, and one of them that poked out to me is the demands one, which, like you said before, it's ag demands, and it's based basically on kind of static population, socioeconomic structure. It basically is just taking future physical changes, temperature, precipitation changes, and estimating what future demands are. And I just wonder, are there going to be efforts that are going to kind of look at demand, not just agricultural demand, but maybe hydropower, energy demands, that would not only integrate the change on the physical side, but also population dynamic side?
Great question. Hopefully, yes, to your question. And there has been some early work. So just in your region here, Pacific Northwest region, Jennifer Johnson has done some experimental work funded through the Science and Technology program, working with the University of Idaho on at least trying to capture some of the economic forces at play affecting surface water management and groundwater management in the context of changing climate and hydrology. So there's some early experimentation on how to do that here. In the context of a basin study, the lower Colorado and the upper Colorado regions worked together on the Colorado River Basin study, the Colorado River Basin Water Supply and Demand Study. It was issued in 2012, and on the demand side, they used scenario planning, recognizing that socioeconomic influences on future water demands are important and really hard to predict, and scenario planning is a useful thought model for getting people to push the bounds of thinking on what's possible and do contingency planning for what's possible. So that might be a paradigm to play with. We have a comment in the room.
Well, I just had a question on that. So are they looking at potential change in crop patterns because of the water, well, timing of water, that sort of thing? So, you know, for example, here now potatoes is a big thing. They may end up changing to row crops or something based on that. Is that the sort of thing they're looking at in that, or?
I don't know the details, but that's the type of a piece of the scenario that you could, that's something you could consider in scenario planning. My understanding of scenario planning is you do a laundry list of potential uncertainties and you try to bundle them into key groups and bookend dimensions, if you will. But I would encourage you to check out the 2012 study report on how they develop demand scenarios and just look up scenario planning in general as maybe a way to start revealing potential uncertainty with socioeconomic influence. Any questions from the phone?
No, not on
Okay. Well, I'll stick around for a little bit longer, but we can go ahead and conclude the seminar. I want to thank everyone for your time and attention and patience, and Jennifer and I will make the slides available somehow to folks, and thanks again.